Hi, my name is Gregorio Lopez. I'm going to be talking about the Laplace transform. Um, the easiest way. The easy way to talk about the Laplace transform is by representing as a waveform, which is not easy. So everybody's going to be scratching their head. How this guy's going to play something that is purely mathematics without mathematics? Okay, I just want to show you how you can see or imagine a Laplace transform without going through all the mathematics of it. Okay, so what we're gonna see here is a representation of everything as a waveform. Everything is represent. You can represent everything as a waveform. Um, a signal, light, what you see, what it moves. You can represent with a waveform. Okay, so it's mostly common in electromagnetic field, but you cannot represent everything with this. This is very complex. Um, it's not easy, but yeah, you can. How in the next slide you will see how complicated it is, but it's a magical tool that you can represent everything and fix everything with that table. This guy Laplace Marcus Laplace is a French guy who dedicates his life to this. I'm sorry for that. I'm playing with the buttons. Um, yeah, this guy spent his life trying to discover these mathematics tools for us without knowing it was gonna be our future. Okay. So right here is the mathematical part of it. The linearity, the time domain, the frequency domain. I mean, it's a really complicated stuff, but we say, okay, fine, we can deal with it. What are we gonna do with it? Okay, this is the representation. These mathematical equations represent this. Okay, here you can see a radio broadcast or your microwave use a wave, a wave, a wavelength to heat up your food. So yeah, um, this very complicated mathematic stuff we use it every day, and we see it every day. Okay, so it's part of our life. It does exist. It's real. It's not imaginary. It does exist. Okay, this XY representation. That's how we used to see it. Um, so yeah, we have two plane, the X plane, the Y plane. Then you got the envelope over here, and this is a waveform that we are used to seeing on school on every explanation that we see. But how can this be the one who heat up your food? It's kind of, you need more information. I mean, it's it's not enough. Okay, I'm gonna show you a 3D representation on the Laplace one. Now it's more like it. We can see it, actually see in a 3D form. This is the origin, and then you have the Y plane, the X-Y plane, and this is the C plane. Okay, so with the C plane, it's, it could go in through your way or all the way around all the side, all the way, but we can't calculate all the way at the same time. You gotta, pinpoint one side first, and then you determine the other side. So this is what I wanna show you this slide represent what I'm really want to show you. This is the 3D representation of the Laplace transform. When you can see f of t right here, right? It's a frequency domain. It's a real, so it's meaning that it's the x, right? And here is the imaginary that you can say is the y, but it's polar, right? And this is the c plane, okay, coming toward you with attenuation, and this is the envelope. For me, it was a really big breakthrough because I was always looking numbers and doing calculations on here, converting from time domain to frequency domain. I really didn't know what I was doing until I saw this light. This light showed me the light because you can see the envelope right over here, right on top of every curve point or signal, right? So you can represent everything with this, okay? That's all I wanted to show you. Thanks for watching me.